My name is Csaba. It's my second time talking here, and I'm really pleased to come back. And I will talk about some macOS bugs today, partially also about local privilege escalation on macOS, but that's just part of the entire story. So a few words about myself. Right now, I'm working as a red teamer. I was in a blue team for 5 years before, and I think red team is much more fun, just as Hugo said. But I think a successful red team will make the blue team also more successful. So the two teams really shouldn't look on each other as enemies. They are there for the same purpose, to improve the security at the company, and they should actually improve each other, and that's very important. Sometimes I hear stories that the two teams look on each other as enemies, but that shouldn't be the case. It should be really like a purple team. So I also maintain a Python toolkit for easing kernel exploitation. I have a wife, 2 kids. They are with me in Göteborg. They are doing the sightseeing and fun. I like to do hiking and yoga in my free time, beyond doing security stuff. So I mentioned that the privilege escalation vulnerability in macOS is just part of the entire presentation. What I try to do here is making a story or showing a story, because originally when I started my research, I didn't look for a macOS bug or a privilege escalation issue. I started somewhere completely else, and I started to go down the rabbit hole and went down and down, and I got completely distracted from my original research. And I think this is how many times research is actually happening. Can I start this timer somehow? Yeah, cool. So what I will talk about first, I will talk a few words about dylib hijacking on macOS. What's that? Then how we can subvert the installation process on macOS. How we can develop an app for the App Store. Then I will talk about the privilege escalation on High Sierra. Then also about how we can modify installers on macOS, how we can redistribute paid apps, and at the end also about another kind of the same privilege escalation, but on MOHA. So originally I wanted to find a dylib hijacking vulnerability in a given application, so that's where I started the entire research. I didn't find, but it involved other things. But what is dylib hijacking? There is a guy called Patrick Wardle who did this entire research on dylib hijacking on macOS a couple of years ago. You can watch his presentation, which is pretty cool, on YouTube. He did it at DEF CON or Black Hat, I think. So this is just a very, very short and brief summary of his research, just so you understand what this stuff is. How many people use macOS here? Oh, that's a lot. So for those who don't know, a dylib is a dynamic library, and it's like DLL on Windows, just this one is on macOS. So there are 2 types of dylib hijacking on macOS. The first type is weak loading of dylibs. Basically, there is a loader called the lc load weak dylib function. Whenever it tries to load a dylib from the file system, it will check if it's there. Now, if it's not there, then it doesn't really care. It will still load the application, so your application will still work without this dylib. In that case, what you can do is, if the application is trying to load something which is not there, you can just place your malicious dylib there and get it loaded and get command execution on the system. So that's pretty easy. The second type is the run path dependent dylibs. This is, in its logic, it's very similar to how DLL hijacking is usually done on Windows. So basically, the loader on macOS will have a search path, and it will search the required dylib through those paths. And if it doesn't find it on the first path, it will go to the second, third, and so on. And once it finds the dylib, it will load it. Now, it will use the first one that it finds. So what you can do is, when it goes through the search, and there is no hit for the first search, then you can place your dylib there, and then it will be loaded, and you can get command execution. Again, that's also pretty easy. So how do you find applications that are vulnerable? You take Patrick's DHS tool, run it, and get the results. So it will give you all the applications which are vulnerable. It couldn't be easier. There is another thing you can do. If you go to the terminal, you can type in this dyld print airpaths to 1, and whenever you try to load or start an application, it will print to you that airpaths fail to expanding, and it will give you the entire path where it tried to find the dylib. And basically, you can use that path and place your file there. How we exploit these vulnerabilities? You make a code, C code. This is a dummy example. There is a constructor that it will be called whenever your executable is being run. You compile it. You have to fix your dylib. The dylib has to fulfill some requirements, like the version have to be the one that the application is looking for, and it also has to export the same function as the original one. And that's it. Now, oops. To fix the dylib, there is a tool created by, again, Patrick, who did this research. It's a Python script. You give it your dylib, you give it the original one, which is working, and it will fix the version for you. It will update its export table, and your dylib actually will refer back to the original one, because whenever the application is loading your dylib, you still want the application to function. So it will refer back to the original dylib for the actual function implementation. So your application will still work, and nothing will be broken. Again, this entire finding the exploits or the vulnerable application and actually exploiting it, it's very, very easy. There are many cases, so there are a bunch of these in Microsoft Office. The problem is that if you install Microsoft Office on a macOS, you install it as root. So as a user, even if you are an admin, you are not root, so you cannot just place a file into the Microsoft Office folder. You have to authenticate to elevate your privileges. And so because you need root privileges to place a dylib into Microsoft Office folder, Microsoft said they don't really consider this as a security bug. Avira had the same issue. They said they will actually fix it. And there are many other cases, like Xcode is full of these bugs. But again, the Xcode is installed as root. So you actually have to be root to exploit these vulnerabilities. So, and this is where I get distracted, because what I run into is that I need root privileges to place a malicious or my dylib into these applications folders. So I cannot just do a hijacking. And I started to wonder, okay, what I can do about it. And anyway, why applications are there as root. And if you actually look on the applications folder in macOS, you will run into two cases. In one case, the actual application folder will be owned by root, and in some cases, the application is owned by the user itself. I'm talking here about an admin user, not like a regular user. There are these cases. And I started, I started looking into this. How do I get there? In which cases it's owned by root, in which cases it's owned by the user. If you install an application from the App Store, then the application is owned by root. If you install a package, most of the cases it will require elevation, and again, it will be owned by root. There is a third case when you download an application and you just drag and drop the application to the applications folder. In that case, it will be owned by you. And that's the only case when you actually own the application and you are free to write into its folder. And I started to think, okay, can I bypass this restriction? And the answer is yes, of course. Otherwise, I wouldn't be here, or it would be a very short talk. Before I go into the details, a couple of tools that can be used for monitoring on macOS. One is FireEye Monitor app. If you are familiar with sysinternal's proc1 for Windows, this is pretty much almost the same or very similar for macOS. It will monitor events, like process events, file system events, network events for you. Oops. Then you have the Objective-C. Patrick Wardle, the same guy who talked about dylib hijacking, he's the guy developing all these Objective-C tools. He has a proc-info library and also an example executable which can be used for process monitoring on macOS. His example executable will log you plenty of data, like if you start a process, it will give you the process ID, who is the user running it, what are the arguments, what's the signature of the file, and so on, who is the parent, and plenty of information, and it's pretty good. If you want to do file system monitoring, then you can use the FS usage tool. Now, this will give you a whole lot of information. I have no idea about 99.9% of the data it prints out. This is super detailed. I think you need to do very, very good filtering if you actually want to get any useful data out of it. It can easily generate you hundreds of megabytes of data in seconds. Sorry. So the first case, how we can bypass root permissions in case of the App Store applications. So how we can drop a file to the applications folder, which is owned by root. So you record the folder structure. So for those who don't know, an application on macOS, so the .app extension is basically a collection of files. It's a folder structure, basically. You record the folder structure, you explore where do you want to drop your file, basically. You delete the application. So on macOS, if you go to the launchpad, you can delete the App Store applications as a normal user. You don't have to authenticate. You can just delete the application. Then you recreate the folders. Now, you as an admin user have write access to the application folder. So let's say I have this parcel.app. I can recreate the folder, any folders, and I can drop there any file I want. Now you reinstall the application, and there you go. Your application will be installed on top of the folders you created. And when you install an application from the App Store, again, you don't have to authenticate to be root. You can just say, OK, install this application or something like that. When you buy the application for the first time, you have to enter your Apple ID password unless you saved it as a cached password for free apps. But this is also not for elevating your privileges because you are not entering your local user password, you are entering your Apple ID password. So this is pretty easy, and you can drop basically any file to the application folder. Now this is fixed today, so it no longer works. I will talk about that later. And it's a bit like, if I want to compare it to the Windows world, it's like the admin user having write access to the program files. Now on Windows, the admin user has the write access to the program files folder, but only if it's running as high integrity mode. And if you go from medium to high, then you get this nice UAC prompt to authenticate to be admin, which is usually just say yes, you want to do it. But Microsoft doesn't consider this as a security boundary. Now on macOS, if you go from admin to root, that is a second security boundary. So I started to think that, OK, nice, I can drop a file to an application folder, but can I do something else? What about symlinks? So what I discovered is that symlinks were followed. The installer, which is installing the App Store files, is running as root, and it will follow symlinks. And it will drop or install files where your symlink is pointing to. So basically, you can drop any file that is in the application package almost anywhere on the file system. I'm saying almost because, yeah, first how you do it. So again, you see where do you want to drop it. You delete the application. You recreate the folders, you create a symlink, you reinstall the application. Now, in this case, this is the symlink. The macOS folder is the one containing the main executable, and it's pointing to the opt folder, which means that anything in this folder will be put into this one when the application is installed. That's kind of cool. But what we cannot do. So on macOS, if the folder is protected by zip, you cannot write there even if you are running as root. And you cannot overwrite any file you want. Like, what I wanted to do is, let's say I have a file called A somewhere, and I have another file called B, in the actual application package, and I want that B to replace A. Now, I spent plenty of hours with experimenting with this, and I realized that I cannot do it. And I run a very simple experiment. The reason you cannot do it is because the app is moved into the application folder. So when you first download so when you install the application from the App Store, it's downloaded to one location. It's undergoing some checks, and then it's being moved to the applications folder. So I did a simple experiment. I created a file called A. I put into some content. Then I created a symlink, B, pointing to A. So you see I have a file A, and I have B pointing to A. Now, if I print out the contents of B, that will give me the contents of the file A. If I write into B, and then again print out the contents of B, we will see that it's being written into A, basically. Now, what I want to do is have a third file called C. You can see it here. You have A, B pointing to A, and C. And I want to move C into B. And my hope would be that the contents of C are being written into A. But that's not the case. So what's happening is basically C is overwriting B, and we no longer have a symlink pointing to A. So I cannot take a file and put its contents into some other file I want to. But still, I can drop all the App Store files anywhere on the file system. And I started to think, can I get like root privileges with this method? What way can I achieve root with dropping these files? And I had a couple of ideas. Like, let's say I have a file in the App Store in a given application which has the same name, exact same name, of an executable which is already running as root on my local system. In that case, I can just replace that file because they call the same. Or macOS is originally based on FreeBSD, so there is cron job, cron tasks. I can take a file that is named as root, and it has a cron job inside it, and place it in the usrlib cron tabs folder. Maybe there are no such files in the App Store, but you create your own app, and then potentially you can push this to the App Store. Or you can do the same with dylibs, basically. So at this point, I said, okay, I'm unlikely to find any file in the App Store that will satisfy my needs. Actually, Xcode has a couple of cron job files, but they are not named as root. So the cron job file have to have the name of root in order it to be executed as root. And there are also no apps that I found that could replace another legitimate application. So I was, I'm lazy. I will just send this to Apple that there is a theoretical privilege escalation on macOS, and I hope they will fix it. Now they came back and they said, our vetting process will find the malicious apps. And I mean, okay, this is not what I meant. The application is not malicious. It's you use the application in a malicious way. So we had some miscommunications there. And I said, okay, I will try harder, and I will create an app to show you that, yes, this can be done. Now, I never coded in Objective-C or Swift, and this was the first. This is why I wanted to avoid this. So I started to plan an application, and it had to be some useful application. So I decided I will do an application which can edit or create cron job files. I purchased the developer ID, and when it came to the language of choice, I decided to go with Swift because I hated the syntax of Objective-C. So I went on and learned Swift through a CBT. It turned out that there is Swift 1, 2, 3, 4, and they are all different in their syntax a little bit. But eventually I learned Swift, and I created an application. Now, how do you push an application to the store? First, you register a bundle ID. This is like the com.mycompany.my name of the application or whatever. You create an application, populate all the details, and you can upload via Xcode to the store. It's pretty straightforward. And then I created my app and started the submission. And then you have this time issue. If you make a mistake in your app, it will have a cost of 24 hours because that's the average time it takes for Apple to review your submission. And it can be super annoying when you know that you are very close to making a successful exploit and you make a small mistake and then you need to wait 1 day. And so this is what happened. I made my first push, waited 24 hours, and they rejected it. And they said, there is no proper closing of the application. So when I press the X button, the application doesn't exit. This is like a one-line fix for the application. So I pushed it again, fixed it, pushed it again. It got actually approved. And then I realized that it doesn't work on MOHA. And I was really sad. I said, no problem. I have a High Sierra VM, and I will try it there. And then when I tried to install it on High Sierra, the application said the minimum OS requirement is MOHA. And I mean, oh no. This is like a setting for the application to compile it for High Sierra, MOHA, Sierra, whatever you want. But again, it's 24-hour waiting for publishing it again. It got approved eventually. And yes, it worked on High Sierra. This is the application. So actually, I created a useful application. So you can like create cron job files. Recently, I realized that people are using this application because it's still in the App Store. I don't think anyone uses it as I use it, but you can use it legitimately. So how privilege escalation is working. So this application has a couple of examples in it, like an example for root, which we run this script every minute. You recreate the folders, you install the application, you create the script file, and you get the terminal running as root. But let's see how it works in a minute. They actually fixed it, so it stopped working. And more details on the fix later. So this was back last October. And that time, I thought that the issue is fixed. And I never really done a proper verification of the fix itself, how they fixed it. It turned out later on that they didn't fix it the way it should have been fixed. So I have a video showing this. So I will do some forwards here. So this is the application from the App Store. I go into the application folder. We can see it's not there right now. And I'm running as a normal user, not as root. I will create the application folder and all the required directories. All the example files are on different files in the resources folder inside the application. So what I do is I'm redirecting the resources folder into the cron job folder. That folder is not listable for the normal users, so I have to do sudo to show that it's empty right now. And then I go ahead and install the application. And then if we list again the contents of the cron job folder, we can see that it was populated and we have this root user there. A couple of others, but who cares? This is what we care about. And what's inside the root cron job file is basically that script I showed you. So it will try to execute this script every minute. As it's in the applications folder, you as an admin user have write access to that folder. So we can just create it. And we will do a very simple shell script, start terminal. We give it executable rights, otherwise it will not run. We are still running as normal user, and it's 17 on my VM. In reality, it was pretty late. And once it will switch to 17, we will get another terminal starting up by the cron job folder. This is the time I can drink. Yeah, 17. We have a new terminal, which is running as root. So basically, without doing anything, I got root access with abusing the installer. The other case, when you have a package file, if you want to do the same trick, you can do, but you can also infect an installer, so you can place your file in the installer itself. It's not really a bypass, and there are a couple of issues. If you modify the package file, it will break its signatures, and then Gatekeeper will block it. And you need a way to infect the package file. Do a man in the middle, or infect it, and then send it to the user. And it will actually also break the application signatures, but Gatekeeper will not care about, because it will only verify the package. So how can we infect an installer? We take the package file, unpack it. There is a payload inside the package. We decompress that payload. You embed your file. You recompress the application into the payload. You clean up the junk. You repackage the file. And then on your new package, you have the file. Again, it's not that effective. You can do it, but for the distributing paid apps, so what I also noticed that if there is a paid application in the App Store, what I can do, take it and run it somewhere else. And that's it, basically. Interestingly, most of the times, there is no verification by the application if it was purchased by the user who is running it. As I understand from Apple, you can do that, but by default, Apple itself doesn't do this verification. So if you buy an application, you can just make a package file. There is an App Store extract utility you can download from GitHub, and it will do it for you. You can give it to somewhere else, and it will run. Probably in-app purchases won't work, but it's still weird to me, at least, to be honest. Now, going back to the privilege escalation, I said that it stopped working on MOHA. And it turned out that it wasn't properly fixed, because what happened, I made this POC with the cron tab folder, and on MOHA, the installer had no access to the cron tab folder, so I couldn't drop their files. And I thought that it was ultimately fixed, but it turned out that it wasn't, because, okay, you cannot drop files to the cron tab folder, but you can still drop files to many other sensitive locations, like launch daemon, which is another startup folder. And if you drop a plist file into the launch daemon folder, it will be executed as root upon boot. So I decided to do a second POC that's called startup. Very same approach. It has example files. And this time you target the launch daemon folder. And I sent the second report to Apple. And eventually, this has been fixed like 2 weeks ago. So this is how it worked in MOHA. What we will do is, again, create all the necessary files or folders, and then we will create a symlink pointing to the launch daemon folder. And I will list the contents of that folder. There are some other stuff already in it, but there is nothing about the other stuff. I go download the application. Again, no prompt for elevation. I list the contents again, and there are 2 new plist files that coming from this startup application. And if we list the contents of this file, we can see that upon boot time, run it load, it will execute that script. So I go to the application scripts, and I have a bind shell Python script. It will basically create a bind shell when executed. And I need to reboot the computer for this. So let's reboot. And now if I log in, and we list the open network connections. So we can see I'm running as the normal user again. If I list there is a listening port on elite, and I can just telnet to it. That's a bind shell. And yeah, you got root. Again. So, but finally it was fixed. So how it was fixed? I hope I will not spoiler Game of Thrones for anyone here. This is how the fix is working. You place your files as before. You create the application folder, you place your files there, and then the installer process comes and wipes it all. But if you want to do it, so check it more precisely what happens. This is a screenshot for the FireEye monitor tool. And finally, this is a proper way fixing the vulnerability. What happens when you install an application? So I tested with the cron tab creator, in this case, my very first POC. What it will do is you have this folder here that you created in the application folder, and it will be moved to the install sandbox trash somewhere. So basically, it's all deleted. And it's basically eliminating the other problem as well, that when you cannot place a file in the application folder because it will be just wiped. And with that, because it's wiped, your symlinks are wiped, everything is wiped, so you can no longer do this trick with the privilege escalation with abusing the symlinks. Closing thoughts, so now this has been fixed, but for the other case, if you have an application in the App Store that you expect users paying for it, it's best if you do some verification if the user who runs it purchased it. I have no idea how to do it, but that's maybe if you don't want your application to be redistributed, maybe it's worth doing. Thank you.
Okay. Thank you, Csaba. Do we have any questions from the audience? We have one over here. All right, let me run over. Who was it? Yep, there you go.
Thanks for the information. Did you try the same thing with Android app?
With Android?
Yeah.
No. I tried the same with iPhone. The thing with iPhone is that you are really running in a sandbox and you can't do anything. So you cannot just write to the application folder on iPhone. And I checked the very same trick on Ubuntu, which also has an app store, but it works completely differently and you cannot do the same trick in Ubuntu.
Microsoft app?
So,
Microsoft app? Did you try with the Microsoft app?
No.
Okay, anyone else? Let's see, all right, over here.
Thank you for a great presentation. I was thinking, did Apple reward you in any way for these findings? Like,
no reward.
did they say like thank you or like send you a diploma for finding something or some cash?
No, so Apple doesn't really have a bug bounty only for, so they have a bug bounty only for iOS and it's invitation based only. Otherwise they will thank you and that's it.
Okay, do we have any more questions? Try to catch my eye? No? All right. if that's it, thank you, Csaba, for a great presentation.
Thank you.